again everyone, Bob Martin with the Nautilus Dry Docks, and this is going to be a series of construction videos on the buildup of a 1/50th scale British Upholder class submarine. It's also known as the Victoria class Canadian submarine. The Canadian military bought these, or a series of these from the British military. This will be a fairly straightforward build. There's not going to be a lot of bells and whistles, so if this is something that you're interested in, by all means follow along and you should end up with a fully functional RC submarine. So let's take a look at what you get when you buy the kit. Alright, this is the hull set that you get when you purchase the model kit. Obviously you've got the upper, lower hull, separate sail piece. Layup is like a polyester resin. It's exceptionally well done, very clean. And the thing that I love about these OTW boats is this flange, both on the upper and lower hull. It really lends a lot of rigidity to the hull, keeps everything aligned really well. You'll get a set of blueprints, this absolutely gorgeous brass propeller that's bespoke to this model, some generic build-up photos on DVD, a few cast white metal pieces, bushings for your control surfaces, and then of course your control surfaces themselves. And those are cast resin with embedded stainless steel shafts. And then you also get a big stainless steel drive shaft with your drive bushings on the back there as well. This is the the guts of the model. This is an OTW 4 1/4 inch diameter single shaft drive unit. What you are going to need to add to it, that does not come with the kit. You're going to need standard servos. In this particular case, I've got some Futaba 3003 servos. I'm going to be adding this VEX 6-channel computerized radio with 6-channel receiver, an 82 pitch controller, my remote on-off switch, fuse holder. Just as a brief overview of the cylinder, these are one of my favorite cylinders to work with because they're really robust, they work really well, they're very precise. You got your main seal in the back here, and this is adjustable. This is something that we're going to need to pay attention to later on. You can actually adjust how hard it seals against the shaft by tightening this screw at the back. We've got bellows seals for our stainless steel output shafts for our rudder and rear dive plane outputs. Big beefy main drive motor equipment tray. We've got the throughput for all of our servo and power leads, our main ballast pump, the ballast solenoid, the ballast controller with integrated fail-safe, and that's pretty well it. It's a simple unit, but once it's functional, again, very, very reliable and very, very precise. Alright, with most of my builds, I like to begin by getting the watertight cylinder all set up, because once that's put together, it will dictate where your linkages are going to need to be set in the model itself. So again, I like to start with the watertight cylinder. What we're going to do to get started, we're just going to take the brass knurled nuts off of the end of both sides, and we're going to basically disassemble the cylinder. So the rear bulkhead comes off and the equipment tray comes out. You're going to need to disassemble the power lead in order to get this apart. And there we go. This is our rear equipment tray with the motor, and it comes with the sub 10 electronic speed controller. That's a nice speed controller. It's a 40 amp speed controller with a larger BEC module to run all of your peripherals on it. So again, let's start by disassembling the cylinder, and then we're going to start installing all the gizmos that go in it. All right, I am going to start by installing the servos into the rear equipment tray. Unfortunately, the cutouts are typically about 1 millimeter too narrow. So what you're going to need to do is take a file and open up the inside edge about 1 millimeter. Length is okay. The width needs to be opened up. Maybe they've got metric servos in the UK, but unfortunately standard servos, Futaba servos, you're going to need to open them up just a little bit more. Alright, so my servos have now been put in place, and obviously they are a little bit wiggly. So what we're going to need to do next is drill out the holes, grab the screws from the supplied package, and bolt down our servos. Alright, I've got one installed there, and I just wanted to touch really quickly on the installation. There are these rubber stoppers, and the correct manner of installation is to slip these underneath, matching up the tab and the notch there. And then once that's in place, you slip these little bushings in on the top, you know, kind of like that. And that gives it a little bit of vibration isolation, which actually helps with the pitch controller later on, because it really does not like vibration at all. So again, just slip the rubber stopper or underneath that rubber flange, press the and I just popped that one out, but press the bushing in place and then lock it down. The other thing I want you to note is that you cannot utilize the inside holes because it will hit your speed controller. So 3 screws to hold down each one of the servos. Alright, got my servos installed, bolted down, and again, not the inside ones there to make sure we don't hit our very expensive speed controller. Now, since we're here anyway, I have a little sticker, suggested place for receiver. We're just going to put the receiver in place. You're going to want to offset that. I would line up the rear edge with the rear edge of the servo there, so you have lots of room to plug everything in. And in order to do that, we're going to use some simple 2-sided tape, adhere that into position, and then we're going to move on to getting some power. Alright, got my receiver in place. That's locked down really well. Now what I want to do before we go any further here is take our radio, and we're going to pop out the stock transmitter crystal, and we're going to replace it with the one that came bundled with the receiver. So this is channel 81. This is the 81 receiver crystal. Plugs into the side there. Make sure that it's seated really well. And you should be ready to go once we get some power in there. Alright, while I've got my soldering gun warming up, let's take a look at our remote on-off switch here. It's a little circuit board. It fits nicely inside the OTW watertight cylinder. Here's our remote key fobs. What we're going to do here, we're actually going to snip off most of these leads, and we're going to be soldering directly to the bottom of the board. And there's 4 places that you really want to look there. There's the big globs of solder, and if you look on the top, fortunately everything is labeled in terms of where it goes. So we've got 2 ground wires. One is for power in and one is for the power out. We've got the main positive power out, which is labeled out right in the center of the board. We got power in, which is tucked right next to these ground wires on the inside there. And then we've got our antenna, which runs on the outside there. So what we're going to end up doing, we're going to cut off the heat shrink here that's bundling everything together. And when you get this, actually everything is labeled as well on the wires, but it's also on the board. So again, what we'll be doing is we'll be soldering to the bottom. So what I'm going to do now, I am actually just going to cut the wires right off of the circuit board because we're not going to use them. And I'm going to maintain the antenna, obviously. So now we got kind of a clean board to work with, and we're going to solder to the bottom. Now to prepare for that, we're going to snip off the Tamiya connector, which I hate Tamiya connectors, from the board, strip back our wires. These are really nice silicone wires that come with the kit. Twist these off, and then we're going to be soldering these leads directly to the circuit board, and then we're going to need to do the same thing on the other side, on the bulkhead side. Snip off the lead, or the connector, sorry, and then strip back the wires. And then once my soldering gun heats up here in a moment, we'll start soldering everything together. The other thing that we're going to want to do is grab our fuse holder, because we're going to put this in line here as well, just for a little bit of added safety. Alright, let's take a look at what I got going on here, because I'm going to modify things a little bit to make sure that we incorporate everything. Now what I'm going to end up doing, I'm going to end up taking off the positive lead off of the bulkhead, and I'm going to be putting on the fuse holder here. So this will be the first thing that power goes through. I've attached a connector on the back there, a ring connector that'll bolt on to that point. So these two are going to get connected to a Dean's connector, and then the other end of the Dean's connector will be onto the remote on-off switch, so that you can disconnect the bulkhead and detach it from the entire assembly. Makes things a little bit more versatile down the road. The other thing that I've done, I've grabbed a little length of negative black wire here of the same gauge. I've connected that together to the negative lead in for the power of the main unit, and those are going to get powered to the negative and positive power outs of this unit. So I'm going to go ahead and wet all of the connectors with solder, and then we're going to go about soldering everything together. Okay, that's all done. Let's take a look at what we've got here. Power leads. This is going to be power in to the unit. Connects to the ground, which also connects to the main unit. Power into the center point, power out on the outer point. And on the other side, we have got our fuse holder wired in line between the power in connector on the outside, connector to the remote switch, and then we've got our ground, which of course bypasses everything. And I'm going to select a 15 amp mini fuse, press that into place, and once we connect this all together, we've got a full power distribution circuit that should in theory power our unit. Alright, now what I want to do is mount the circuit board in the boat, and this is where I'm going to put it, right tucked next to the pump there. For preparation for that, I've notched out the equipment tray with my Dremel just to allow these wires to be able to travel around that corner without getting pinched. Now because we've soldered to the bottom of the board, this board is standing proud of the equipment tray, so I've just cut two of these little plastic blocks. They're just little 1/4 inch thick plastic blocks, and what I'm going to do, I'm going to mark out the corner holes and glue these in place on the equipment tray, drill in some holes, and then I'll be able to bolt that down to the equipment tray, and it'll remain nice and steady. Alright, now it is time to test everything to see how it works. I've got a 12 amp or a 12 volt battery here. I'm going to go ahead and connect that. You can see no power has gone through because of course we've got our remote switch. I'm going to turn on my radio. Then what I'm going to do, I'm going to flip this over. I'm going to get access to my electronic speed controller. Now what I'm going to do, I'm going to hit the on button. You're going to hear a click. The pump is going to cycle for a second. And then before 2 or 3 seconds goes up, I'm going to press the set button on my electronic speed controller, and then we're going to go into a configuration mode or a setup mode so that we get the full range of travel there. So hit on, press the button, you get a solid green light. What I'm going to do is going to press full forward, full reverse, and back to neutral. Now we got red light, green light. Everything is set up for all of our endpoints. Just going to do a quick test here so we can make sure our servos are working. Looks like everything is in really good shape. And the other thing this has done is centered the servos. So what we'll be able to do at this point is pop these horns off, center them so that they're perfectly perpendicular so that we get full range of travel. So pretty happy so far. Everything seems to be functional. Okay, we are going to move on to the installation of the forward servo, and this is going to operate our bow planes. Again, standard servo, and I've just got some standard plastic stock here, and I cut it into some rectangles of plastic, and basically these are going to create a mounting frame for the servo. Notch this out so we'll be able to install the servo in there with that power lead coming out. Pieces will go like that, and then these will go across to form the framework that will hold it in place. I've got this set up so that I can mock up where everything's going to go, and basically what I'm going to do is I'm just going to mount it flush with the equipment tray and then do a little bend in the linkage to get it to line up. So I'm going to go ahead, glue that framework right to the equipment tray, and our servo will be mounted in place. Alright, I have gone ahead and installed my framework there for the servo. I've also gone ahead, connected power, turned everything on so that we'll be able to check operation of the servo. This is hooked up on channel 2. That's going to be our forward dive planes right there. So next step is going to be to set our rear bulkhead in place, and you can do that without that sleeve in there. You just set the rods in place, push everything nice and tight, and then you can make your bends in your linkage to connect to your servo output, and I'll show you what that looks like here in a moment after I get it all bent up. Alright, here is the completed setup. I've got 2 bends, and these are compound bends because I needed to shoot the linkage over by about 1 centimeter and down by about 1 centimeter. So each one of these bends does so accordingly, and then we've connected to the secondmost hole on the outside there. Don't want too much travel, but of course you don't want too little travel. So we're going to start there. It'll be easy to move it back and forth if we need to. But as you can see here, I'm just going to try and hold things in place. Moves without binding, which is very important. And ultimately your goal is to have this output shaft at the neutral position, perfectly perpendicular to the center line or the longitudinal axis of your cylinder. So do that and you will be in good shape. Alright, the last thing we need to do is connect the servo properly, run the servo wires through that center channel to the receiver. And fortunately, there is a pre-run cable. You can see it running through the middle of the cylinder there. Just connect it to the end of the lead. We're going to bundle this up neatly and keep it tethered down at the back so it doesn't interfere with anything. And then, as I said, what you may want to do at this point is mark the other end of the lead, either color code it or scratch it in so that you know where that goes, because you'll have 2, one for the ballast system and one for the servo. You want to make sure that you get them connected to the proper ports in your receiver. Alright, the forward section is now, for the most part, complete. I've tidied up my cables here. What I've done is I've got the equipment tray sitting in place. I've reconnected the silicone hose on the bottom. All the connections are made. What I did is I slipped the bulkhead off the end, and what we're going to do now is put our cylinder body over top of everything. And now we're going to reinstall our bulkhead here. So we're going to need to make the connection for the battery, for the silicone hose, and put the linkage through the bellows seal. This will take a little bit of playing around. Once you have it in place, accessing this section of the cylinder is not necessary unless there is a leak that you need to address or for maintenance and upgrades. So let's go ahead and get that installed, and we'll tighten it down and we can move to the rear section. Alright, for this next step I am going to be using a couple of 3D printed parts, and specifically these two 3D printed parts right here. Just simple plastic brackets that I designed in 3D and printed out on my printer. I've got some other 3D printed parts that are going to go into this construction. Now, just want to make a note here that 3D printing is a great tool, but basically everything that is done with it can be recreated by hand if you do not have access to the software or hardware needed to do this. These are all periscope additions, and this is the sail bridge area. And then I've also got 3D printed brackets that go inside the hull, and those maintain alignment of the hull, and they also create an area to hold the cylinder down inside and also retain it. So the bolts fit inside these holes that you see here, and then this clamps down on the back to hold it in place. Now I'll be offering these 3D printed parts as an upgrade for this kit if you are interested, but like I said, don't feel like you need to have them. All of this can be replicated with simple plastic sheet stock, a little bit of time and energy. Alright, what we are going to do next is attach this rear equipment tray to the rear bulkhead. And the reason that I like to do this is so that the linkages for the outputs here are basically locked in place, so that when you pull this out, it's not all moving around and you get all sorts of alignment issues. So what I'm going to do basically is take these little brackets that I showed you earlier. We're going to glue those on right here, and then we're going to glue that to that forward bulkhead. So let's start by putting these brackets in place. And again, you don't need 3D printed brackets. A piece of thick plastic cut in a triangle like this would work perfectly fine. Alright, I have adhered the brackets to the rear section of the equipment tray. Now what I'm going to do, I'm going to just put some of this thick CA on the faces there. Now what you want to do is set your rear bulkhead in place, and again I've disconnected the motor from the tray. That's just a Tamiya connector there. Set this in place, it's locked in place, and now I'm going to slip the equipment tray into the cylinder, and I'm going to press it forward until it rests against that bulkhead. And then I'm going to let that cure. Okay, as you can see, I have connected the stainless steel linkages to the two servos. I've bent it again in such a manner that we have a perfectly straight shot out the back with no binding as it actuates. The last thing that we're going to want to do is address the receiver antenna, and in order to do that I have drilled a series of 1/16 inch holes in the equipment tray. And you can see them. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 holes. And basically what we're going to do is we're going to unravel the antenna, string it through these holes, and that'll extend the antenna and allow us to get much better reception when we are under the water. And here is the final routing of the receiver antenna. Basically, again, spreading it out over as much area as possible so that you got the best attenuation of radio signal into the receiver. The only thing left to do now is make up all of my connections, clean up the wires, bundle them together nice and neatly, put the cylinder back together, and we'll do a final test. All right, one thing that we are going to want to do now is install our automatic pitch controller. In this particular case, I'm using the excellent automated pitch controller by KMC Designs, the AD2. Comes with full setup instructions, but setup is really simple. I'm going to be putting this on channel 6, which is going to be my stern planes, and those are going to be running basically autonomously 90% of the time, but I do have override capability on the push button switches in the back of the transmitter. I have disconnected the servo from channel 6, and that gets plugged in to the unit, and then the unit gets plugged into the channel 6 output on the receiver. Now basically what we are going to do is mount this right in between these two servos with a little bit of two-sided foam tape, route our cables, and we will be set to go. Okay, just a quick test. I've got just a battery pack plugged into the receiver to give it some juice. You can see that I've got my rudder output working, and this is the pitch control one, and I can actuate that with channel 6. And you can see by tilting the tray, the servo is moving through its travel automatically. Now I have adjusted the AD2 to sensitivity level 2, and you simply do that by hitting the set button, pressing it in, releasing it. It'll flash twice. That'll show you that you're in sensitivity mode 2. I find either 1 or 2 is going to work out the best. 3 is just far too sensitive and twitchy. So even 1 is going to be good for these bigger models. So this all seems to be functioning properly. I'm going to button this back up again. All right, you can see I've got the cylinder connected to all of its respective parts, and I have also put on magnetic linkage connectors. Now you could obviously do mechanical if you want, but I really love the simplicity and convenience of these magnetic versions. I offer these called click-ons on my site under the RC components section. These larger ones have a really strong connection to one another. I've had really good luck with them. Sold in sets of 2, as you can see here, a kind of a male and female, or north and south. The way I've got these set up is done in such a manner that if the linkage gets misaligned, it will push away from the incorrect linkage, and it will jump to the correct one. So that just makes things a little bit easier when you're setting up your linkages and when you're installing your watertight cylinder. The last thing that I want to do is install these waterproof connectors. These are available online. They're basically for trailers. They're rated for about 20 amps, which is more than enough for what we're going to be using them for. And basically they just slip together and lock just like that. They've got a really good seal all around the outside perimeter there, so you don't get any water ingress. You just need to make sure when you attach the leads that you use some heat shrink that has some glue on that. So I'm going to go ahead and do that now, and once that's done, we will go about testing our cylinder. All right, kind of time for final testing. I've hooked up to 12-volt power. I got my radio here. Just going to test out the functionality. We've got our forward dive planes. You can see those working in the back there. Got our rudder. We've got the override for our rear planes. Our pump, ballast pump. And throttle, forward and reverse. So I would say that this is basically ready to go, and we will be putting it in the pool to test for leaks. But I think before we move on to that stage, I'm going to start doing some work on the hull, which is what you're going to see in the next video. Well, there you go, everyone. Thanks for joining me. I hope you found this section of the build blog for the 1/50th scale OTW Upholder interesting, or if not interesting, at least informative. 4 1/4 inch dive module, completely set up, ready to go. As I mentioned, we're going to move on to construction of the hull next. I hope you'll join me. If you have any questions or comments, I'd love to hear from you. Bob at RC-sub.com. Email me anytime. Be sure to visit my website, www.nautilusdrydocks.com. You can buy all this fun stuff. Check out the resources and information that I have there. Thanks again, everyone. We'll catch you next time.